All right, let's just dive right into this explainer, because today we're tackling one of the absolute most mind-bending questions in modern physics. We are literally going to peel back the fabric of reality, unpacking decades of theoretical physics, quantum mechanics, and information theory.
So, are we living in a giant computer simulation? It's a question you've probably heard debated everywhere, right? From sci-fi movies to those deep late-night dorm room chats. But to find the actual answer, we aren't just going to be guessing. We're going to follow some highly specific clues laid out by top physicists and mathematicians to uncover the true nature of our reality.
Section 1, the universe as a computer. We're going to begin our journey by looking at a highly speculative field of science that attempts to reduce literally everything around us down to code. Let's see where this whole simulation idea actually stems from, scientifically speaking.
So instead of thinking of the universe as being made of traditional particles or continuous fields, what if existence is just the output of a massive cellular automaton? Basically, imagine a giant grid of cells operating on simple, repeating rules. This concept is known as digital physics, and it suggests that underneath all the messy, unpredictable physics we see every day, there's actually a crisp, clean computer program running the whole show. Think of classical physics, the kind championed by minds like Einstein, as being kind of analog. It relies on this continuous, smooth space-time where things can theoretically be measured with infinite precision. But digital physics steps in and says, wait a minute, what if reality is actually pixelated? Just like a digital photograph is made up of discrete individual pixels, a digital universe would be built from discrete bits of information, running on deterministic or even probabilistic code.
Now, this idea of a digital universe actually evolved mathematically over nearly a century, well before being fundamentally challenged by recent discoveries. You look back at 1936, and we see Alan Turing laying the groundwork with his ideas on computable numbers. Jump to 1969, and Konrad Zuse publishes a book literally titled Calculating Space, flat out proposing the universe is a digital computer. Then we move into 1989 with John Archibald Wheeler's really famous It from Bit theory, and finally, a massive plot twist in 2025 from physicists Feisel and Cross, which, trust me, we are going to get to in just a moment.
Which brings us to section 2. Everything is just information. Let's see how this digital theory builds on the idea of information itself. Because, if the universe is a computer, what exactly is its data?
All right, enter It from Bit. This was a phrase coined by the absolutely legendary physicist John Archibald Wheeler. Wheeler argued that every physical entity, every it in the universe, derives its existence completely from the answers to binary yes or no questions. I mean, think about that. This implies a photon doesn't actually exist in a definite state until a yes or no question is physically asked by a detector. Like, hey, did the counter register a click during this specific second? The binary yes or no recorded by the equipment, that is the fundamental reality. The physical particle is really just a secondary effect of that underlying information. Wheeler famously said all things physical are information theoretic in origin, and this is a participatory universe. That perfectly captures the view that our physical world is just a byproduct of information processing. And notice how he specifically calls it a participatory universe. That's huge. It means reality isn't just sitting there, passively waiting for us to look at it. The very act of us asking questions and recording binary bits of data is what actually gives rise to the physical universe.
Now, drawing on Gregory Shaitan's algorithmic information theory, if we want to truly understand the universe computationally, we have to compress its data down into a smaller set of rules. I mean, think about it. If a scientific theory is exactly as complicated as the sheer facts it's trying to explain, well, it's pretty much useless, right? Shaitan argues that comprehension is literally compression. A successful theory is just a concise computer program that can churn out all the messy, wildly complex facts of the universe.
So if we compare physics to computer epistemology, the ultimate goal is always to take the uncomputable, absolute chaos of reality and somehow compress it into elegant code. On one hand, you have uncompressed reality, which gives us infinite precision, uncomputable real numbers, and these incredibly complex phenomena. But a computational universe demands the exact opposite. It needs finite bounds, neat little algorithmic bits, and simple, compressed rules. Bottom line, if the universe is a simulation, everything on that chaotic, uncompressed side absolutely must be reducible to neat, compressed code. Moving on to section 3. The observer is everything. Because if the universe is out there processing information and compressing data, we have to ask, who or what is actually observing it? Seriously, take a second and just look around your room. Because according to physicist Carlo Rovelli and his theory of relational quantum mechanics, even that pen sitting on your desk or the table lamp over in the corner, that's an observer. In this framework, there are no observer-independent states. A physical quantity doesn't just have some absolute magical value. It only has a value relative to a specific observer. And the crazy part is, an observer doesn't have to be some conscious human wearing a white lab coat. Literally any physical object can be an observer. Information is really just a physical correlation that happens the second two systems interact.
So if every single object out there, from a tiny electron all the way up to your table lamp, is defining its own relative reality based purely on its interactions, things get incredibly complicated for the simulation hypothesis. Why? Because there's no single objective God's eye view of the simulation. Different observers might give completely different accounts of the exact same sequence of events. Reality, in this sense, is fractured into infinite relational perspectives.
Which sets us up perfectly for Section 4, the ultimate plot twist. Just as we really start to buy into the idea that reality might just be this wildly complex relational software program, recent mathematical proofs drop a massive bombshell.
This brings us to a total mind-bender of a mathematical paradox where computation basically just fails. Have you ever heard of Gödel's incompleteness theorem? It proves that within any logical system, there are statements that are absolutely true but completely impossible to mathematically prove using the rules of that very system. Okay, think of the sentence, "This true statement is not provable." If a computer program can prove it, the statement becomes false, which totally breaks the program's logic. But if the program cannot prove it, then the statement is true, which means the computer program is fundamentally incomplete. We call this a Gödelian truth, and it is a massive, massive roadblock for the whole simulated universe idea. Let's walk through these exact steps published by researchers at UBC Okanagan in 2025, because they definitively prove that no algorithm can fully describe our existence. Step 1. Modern quantum gravity suggests that space and time actually emerge from a much deeper layer of information. Step 2. Because of those Gödelian truths we literally just talked about, getting a complete description of this deep reality requires what's called non-algorithmic understanding, meaning things that are definitely true but simply cannot be computed. Step 3. Any computer simulation, by definition, is strictly algorithmic. It has to run on programmed code, right? Therefore, Step 4. Since reality requires non-algorithmic truths and simulations can only run algorithms, the universe mathematically cannot be a simulation. Honestly, checkmate. Dr. Lawrence Krauss summed this up beautifully, saying, "A complete and consistent description of reality requires something deeper, a form of understanding known as non-algorithmic understanding." This is so vital, you guys, because it reveals that the actual foundation of our physical world exists completely outside the reach of any computer program. The fundamental laws of physics generate space and time, but they can't be contained by them. And they absolutely, definitively cannot be reduced to simple computational arithmetic. And that brings us to our final section, Section 5, Reality Beyond Algorithms. So, what should you actually take away from this profound shift in how we understand physics? Let's bring all these puzzle pieces together. The big takeaway here is that our universe is infinitely more complex, and honestly, more mysterious than just some simple digital matrix. We know that existing digital physics models fail because they flat out violate established quantum phenomena. Take Bell's theorem, for example, which proves particles interact in ways that simple code just cannot explain. We also know, thanks to brilliant minds like Alan Turing, that the universe contains an infinite amount of uncomputable real numbers. And now, we literally have mathematical proof that the deepest layers of reality rely on non-algorithmic understanding. The source code of reality? Well, it isn't code at all. So we've mathematically proven you aren't living in a computer simulation, but you know what? That leaves us with an even bigger, much more beautiful mystery to explore. If the universe is not a program, and it requires a form of understanding that goes entirely beyond algorithmic logic, what exactly is generating the information of reality? It's a massive question, one that physicists are going to be trying to answer for decades to come. And I really hope this explainer gave you a fantastic new framework to think about it.